Good afternoon. Today our video or the lesson is about projectiles. Now I know a few of my students struggle with applying projectiles, or there are silly mistakes here and there they make. But if you listen to what I'm going to tell you, if you keep these points in mind, I'm telling you, you can be assured that it can be handled. Any situation that involves projectile can be solved without an error. As I said, if you keep or if you remember to include or apply all these points that I'm going to tell you today. Now, what's a projectile? The definition, or an object can be termed as a projectile if it is under the influence of a constant force while it is in motion. I said constant force, so there is only one force that will be acting on the object while it is moving. Now, if you just drop an object freely from a height, it's very easy for you to. Now, I believe you'll be in a position to analyze it easily by applying equations of motion. If you're just releasing it, initial speed is 0, so you can g is there, you just find the height and go ahead with the calculations. Or if you throw it, you have an initial speed, accordingly you modify your substitution, you will get it. Now that is about perfect vertical movement. But if we are projecting it sideways, or if you're just throwing an object sideways, then what's happening? It's not only the force that you apply, but once it leaves your hand, are you still applying the force throughout the motion? No. Once it leaves the hand, there is no horizontal force acting on it. But what happens? There is a vertical force that is pulling it down. So while it is moving, or after it leaves your hand or any other object, then the only force that is acted on the object is gravitational force, or the weight of the object, right? Okay, that's about the theory part of it. Now again, one more point to remember: horizontally, is there any other, if you ignore air resistance, then is there any other opposing force? No. So according to Newton's first law, what should happen to the object? It should continue moving in the same direction without any change in its velocity, right? Because there is no other force acting on it. Hence, horizontally, the move or the velocity or the speed does not change, it is constant. But what about vertical? Vertically, you can notice that, or since there is acceleration, the object will gain speed and it is increasing in its velocity or speed downwards. So, in reality, if you're just kicking an object sideways, okay, you've done that in the laboratory also. I'll try to include the video so that you can believe by seeing it as well. If an object is dropped at the same time, what happens? Both of them will hit the floor at the same time, which is another proof that the vertical acceleration is constant. That's the reason the time taken for it to hit the floor is the same, and so on. All right. Now, so how is it different from handling these projectiles and vertical movement? As I said, vertically you don't have to think much, you just have to apply straight away equations of motion, because g, or acceleration due to gravity, is a fixed value. But then what about the object that is moving here? There are two factors, or the movement is in two different planes. There is a vertical plane also, there is movement; horizontal also, there is a movement. So the actual path taken by the object is the resultant of vertical and horizontal. So at any point in time when you take, it is influenced by vertical and horizontal movement, or horizontal acceleration or speed. Hence, if they both were same, then you can combine them both and solve it. Since the horizontally acceleration is 0, vertically acceleration is a fixed value, you cannot combine them both and proceed with calculations. So you must treat the vertical and horizontal calculations and analysis separately. That's a reason for us to deal with projectiles. It's not very similar to this one. Now, point number 1. Though I tell the students, they still skip this step. Please, any projectile question that you're going to solve or analyze, divide it into 2 sections. It will just take few seconds, but I'm telling you, it is worth that time. You will save the time later by avoiding mistakes. Even if you want to check your calculations, you can easily go ahead and check. Alright, what is this? Separate it into vertical and horizontal quantities. Alright, so write down all those quantities that you know of the vertical movement. Horizontally, what are the factors that you know about? You write it, because we are not going to combine these two. Here, acceleration is 0, hence we'll use the formula speed is equal to distance over time. Alright, this theory part I've explained it before. Vertically, it is accelerated, it has got a fixed acceleration, so you will use SWIFT or equations of motion. That's the difference between the two types of calculations. Alright, now in this situation, if you're analyzing this, what happens to the horizontal speed or the velocity? Will that increase or decrease? No, it will remain the same throughout. The reason for it is we're ignoring air resistance, hence horizontally after it leaves there is no force affecting its horizontal movement, hence there is no resultant force, no acceleration, the object will move with the same speed. How about vertically? Vertically at the starting point, will it have any initial vertical speed? No, hence here initial vertical, you can say it is 0 meters per second. Right? Initial vertical is 0 meters per second. Alright. Now, after 1 second to be precise, what will its vertical speed be? It would have gained 9.81 meters per second. So here you have, say, if that denotes 9.81, say this is the same velocity, probably we'll take it as 20 meters per second. Okay. Now this line or the movement of the object is the resultant of these two influences, these two vectors. Okay, if you're plotting, if you're drawing a rectangle and then finding out, the diagonal will be the resultant. So you can notice that is the resultant force. Likewise, if you go ahead and calculate at any point in time, vertically it keeps on increasing, horizontally it remains the same. The resultant of the object is the resultant of the two vectors. Now here, see if this is after 2 seconds, this vertical would have doubled, right? 9.81 into 2, and hence this will be your resultant. So you can notice that way it's going. If you look at it, see the more vertical displacement it has made, you can see that the resultant is coming closer to the vertical. That's the reason, because this vector keeps increasing, this is constant, hence the resultant is more closer to the vertical. Alright, now any other quantity that you know of here, acceleration is 9.81. Now, do we know the final velocity? No. Do we know the time? No. So these two factors, if it is perfect horizontal projection, I've included the term perfect horizontal projection. We are going to discuss another situation as well, then you will understand it better. Here it is just projected horizontally, initial vertical speed is 0, acceleration is 9.81. Here, do we have any quantity? This 20 meters per second will be the speed. So this will be equal to 20 meters per second. Now this distance is what? This horizontal displacement. Okay. Sometimes it's also called as range. Alright, so that's the value that is known to you. Say for example, if the question says the object is pushed from a height of 50 meters. You're asked to find out the time taken and the horizontal displacement or all those unknown quantities that are involved. How do you proceed? You've got the height here. So this is the main confusion students tend to make. When they see a distance, they tend to substitute this here. Right? Vertical height must be used in vertical plane calculations. Horizontal displacement must be substituted here. Getting it? What's a common point between the two? It is the time. The time for it to reach the floor can be used if you know it already, or if you have calculated here, you can take that quantity there and do the substitution. Right? So here displacement is known to you 50 meters. So 3 quantities are known. You can find out the other 2 by using equations of motion. Any equation of motion, you can use it, bring it to there, and you can substitute to get the horizontal displacement. Clear? So 3 points to remember. One is about the theory part, horizontally, how you should be able to describe the movement of the object. Then vertically, how is it changing? You should be able to differentiate both, and then combine them, or use it appropriately in calculations to find out any unknown value. Now, 2 more types. This is case 1. There are 2 more types of common types of projectiles. The other 2 are more or less the same. There are some similarities, so we see it side by side. One is, it's projected at an angle to the horizontal. Earlier it was perfect horizontal projection, here at an angle to the horizontal. This is one type of motion. Another one is projected from the ground at an angle. So this is the third case, this is the second case. Now here it's very similar to the previous case. Only difference is that initial vertical speed, will that be 0 here? Think. It will not be. Because it is moving at an angle, it will have, say if you take that initial speed as u, it will have horizontal and vertical component. Okay, so how do we split that into? Your horizontal component of the speed will be u cos theta and vertical will be u sin theta. So when you're solving questions, if this vertical is horizontal, your u vertical will be u sin theta and your u horizontal will be u cos theta. Alright, the rest are all are the same. A is 9.81 and time you can use it for both, it's the same. Only thing that you have to remember, when you get an angle, you please find the components, and the components is what you have to substitute, not the actual speed. Clear? Now coming to this is slightly different, but since you have angle here, you have to resolve it into horizontal and vertical. Horizontally it is u cos theta, vertically it is u sin theta. But then this object will reach a maximum height and then it will fall down, so you get an inverted parabola. So at the maximum height, what happens to the speed of this, in this plane when it is rising, the speed gradually decreases, and here the final speed at the maximum height will be 0. So here when you write vertical and horizontal, you already have a few values. U vertical is u sin theta, here u horizontal is u cos theta, v is equal to 0 meters per second. The final speed is 0. So that's known to you. What about A? Will it be plus? See, it's going against gravity, so we take that as minus 9.81 meters per second square. And the time, if you find it here, now this time if you use it here, you will get only half the range. You multiply it by 2 to get the whole range. Clear? Because it will take the same time to reach the maximum height, the same time it's going to take to reach the other side as well. So you'll have to, for you to get the total range, then you have to multiply it by 2. Clear? Now there are a few questions that I've given as a worksheet or from past paper questions. Try a few questions, but as I'm telling you, if you find theta at the start of the motion, then remember to find its components and use it appropriately. Alright, and also keep this in mind, vertical and horizontal separated, and if there are any hidden quantities that are already known to you, because perfect horizontal projection, they will not tell you initial vertical is 0. You have to use the theory part of it. You have to think, oh, this is perfect horizontal, initial is 0. So try to get vertically, your main aim is to get 3 quantities, quantities in the vertical side for you to substitute it in any equations of motion, because you need at least 3 to use one equation, right? So your aim is to identify correctly before substitution. I would say once you plug in these values, please go back and verify whether you have written it appropriately and not, mix them both. If you keep these points in mind, I'm sure you will not make any mistakes and you will solve it easily. All right. So take care and see you in another video. Bye.